So now we are seeing this subarray sum divisible by k, right? So you have been given integer array nums, and so basically you have been given an array. This is array nums, and you have been given a number k. The k is basically, yeah, it's just a number given to you. The basically the thing which you have to tell is the number of sub arrays of this array which have the sum divisible by this k. So this is an array. There is a how many number of subarrays there would be, and then basically the sum of subarray would be divisible by k. That subarray will basically increment your count. So basically you need to count all those subarrays which sum is completely divisible by this k. Okay, so there are multiple ways. Okay, first way is basically if this is a sub array, right? How will you say that a subarray is basically divisible by this k? By, you can say, like, by the naive way or brute force way is to generate each subarray. Like for example, this is a particular subarray. Like for this complete array is also subarray. Remaining, this is a subarray. This is a subarray. This is also subarray. So generate all possible subarrays starting from this first index, then from second index, then third, or basically generate all possible subarray. Okay, all subarray you will generate. Okay, and then this is basically n square time complexity. And then if you are not pretty if you don't if you now look out to sum this subarray. Okay, you generated a subarray, and then you sum this element of this subarray, some element of subarray, that would again add up to something like of n time complexity. So this would be into this n square will become into n. Now it will become n cube. Now the subarray sum, basically array sum of all the basically subarray, and then you can check whether it's completely divisible by this or not. You will add counting that or not. So this is basically of n cube approach based on that basically. But one thing which you can do, instead of calculating the sum of subarray every time, like we can do prefix. We can store sum into prefix. So we'll create a prefix array which store the uh, prefix sum for this array. For example, for 0 index, the sum would be 4. Then 4 plus 5 is 9. The sum would be 9 till here. And the 0 again, the 9 will be here. And then 9 minus 2, the sum will be 7 up till here. And the sum will be something like 4 up till here. And now it will be 5 up till here, right? What does this tell me, this prefix array? What does it tell? It tells that, for example, from starting point to this point, sum is 4, and this is sum is 9, this sum is again 9. So you can also, by generating all possible sub array, the starting index and end index. So for example, start index is, let's say I'm taking this sub array, right? 5, 0, minus 2, minus 3. Can I find the sum of this sub array in just O one time? Like this is how prefix array works. So basically, yes, we can. So this index is 1, and this index is I'm talking about the original indexing. So 5 was originally one index, and like it, this is second index, this is third index, and this is fourth index, right? So now 1 to 4, I want the sum between 1 to 4 index. How we can tell? We will go into this prefix array, we will go at the fourth index. Like this is the fourth index. Now I will take this minus, what I will do, 1 से पहले क्या आता है? 0. So 4 minus this 0 पे क्या पड़ा हुआ है prefix sum में? 4. So 4 minus 4, that is 0. So actually इस पूरे सब array का sum 0 है. So I can get the prefix sum in just O one time. That is the second basically थोड़ा सा modification that will make it just reduce this time complexity by n cube to n square, but still it will give TLE. Okay, because 3 into 10 to the power 4, yeah, it will give TLE. Now I'm going to tell you the best approach for this. The logic for this question would be that if you have been given array and you want to return the count of the subarrays having the sum which is divisible by this, so I will keep storing my subarray sum into a map. That we can do. Map of int comma int. I can make a map, and then this will contain all my sum or the subarray till this point. For example, I'll start iterating from 0 for int I equal to 0, and I will go up till n, and I'll just keep on storing the sum plus equal to s plus equal to a of I, nums of I, which is given over here. And the sum variable is starting from 0, and what we do, initialize this m of 0 by 1, because when there is nothing, there is still 0. So basically a map I'm creating which is saying is sum till this point is 0, so we have a sum like something like 0. Now when the sum will become 4, okay, now we know the sum is becoming 4. So the sum is total 4, and basically, is this sum divisible by this 5 or not? Because for example, that's what we want now, that sum of subarray should be divisible by 4. 5. So currently it's not. So let's me add this 5 also. Now the mapping would contain key. Okay, now 4 is present, 9 is present. Okay, now when I am pushing this 9, I will check that key. Okay, 9 is present, but is there something like, now the basically you have a something like 9, but you also have 4. So 4 minus 9, which is equal to this array, right? This is which is equal to this element. 4 minus 9 is equal to 5, and that is basically divisible by 5. So we got actually one sub array. So what you can do, you can check for all the multiples of this, all multiple of this array, right? All multiples of this k, whether this let me tell you one thing. Like this is something, and sum till this point is s, okay, and sum till this point is s minus k. So can you tell me what will be the sum between these two elements? It would be k now, because sum till this part was k, s minus k. Then I added something like some I added some things, and that something sums up to k. That's why till this point it becomes k. So this is basically k, or this can be multiple of k, k into any multiple, k into any multiple. So I'm checking if I'm having something like sum. Do I have, if m dot count or m dot find, do I have something like s minus this multiple of k? If you have something like this, then you will say, okay, now I got basically, you'll do count plus plus, okay? But that's not also a good thing, because this is a good logic, but the logic is basically a modification of this, because for generating all the multiples of k, it will take a lot of time, because you have to generate all the multiples in this range, minus 10 की power 4 to 10 की power 4. Will take a lot of time. So another good logic कि अगर for example currently at this point sum was, let's say, s minus k into m, ठीक है, and let's say x is the basically the all the sum till here, the modulus of the sum with this k, basically the remainder of the sum, uh, like this currently sum is equal to s1. S1 modulo k would be something like, let's say, x, ठीक है, at this point. And after some point I see sum becomes s2, and modulus of k, the remainder of s2 again becomes x. Do you know what does it mean? It means that between this, whatever the sum is actually a complete multiple of k. Because for example, sum till this point is, let's say, let's talk about this example only. What is 4 modulus 5? It's just 4, because 4 is less than 5. What is 9 modulus 5? It's again 4. Which means when the remainder repeat, it means that between this I got a sub array which has a sum which is just multiple of this. This is a pretty decent or pretty famous logic, and standard logic which you have to apply in many questions, that when the remainder repeat itself, when you are continuously doing a running sum, when you are checking the running sum and remainder repeats itself, means the element between these two remainder are actually sum up to something like which is divisible by this k. And let's see another example. For example, let's say 2 3 4 5 6 7, and let's say divisible by 4, right? The divisible by 4, and what is the remainder? 2 remainder 4 would be 2, 3 remainder 4 would be 3, 4 remainder 4 would be 0, right? This is also a good point. Like before this I said that something like 0. So now when the remainder becomes 0, you means this means that okay, you got actually one subarray which has what, which has the okay, okay, okay. Now I'm doing it wrong way, because first of all you have to, if this is the array, then first you need to find the sum value. So some mapping of sum would be something like 2 until this point, and now this is a good given array. So before this the sum is 0, and after this sum becomes 2, and after this sum becomes 5, and after this sum becomes something like 5 plus 4, which is 9. Sum becomes 9 until this point, and after this sum becomes something like 9 plus 5 is equal to 14, right? Now एक तो है कि first we can calculate this 14, and then 14 plus 6 I know 20, and 20 I know 27, right? After this you should see what is the remainder of basically this sum, running sum. So remainder of this running sum up till this point is okay, obviously 2, and this point, if I'm taking remainder modulus 4, I'm taking modulus 4. Let me write it over here. Modulus 4 I'm taking. So this would be 5 modulus 4 would be 1. This 5 9 modulus 4 would be just what would be, it would be 1 again, na? Which means there is 1 4. Yeah, there is a one sub array having some 4. And 14 modulus 4, again it is something like 2, which means till this point the sum was uh, this sum is basically 14. This sum is 2. If I reduce this sum is equal to 12, right or not? 9 plus 3 is 12, which is divided by 4. So and I say that when your remainder is repeating, which means that the between this whatever the sum is actually a multiple of this k. And that's about the whole logic. That's what you have to see. You just don't need to see this s, you need to see remainder of is s. So nums modulus k, and this nums can be negative. So in that cases it will create some problem because there are negative also. So plus k for that, and then modulus k. This is how much you take the modulus of negative elements. You need to add plus k and then again take modulo. That's about it. And then again you'll take some modulo k. So this is basically because this can also go beyond k. So then you will take some modulus k, and then you will check how many times this sum modulus k has been present or not. So m of s, which you will add in your counter, c plus is equal to m of s, and then you will say okay, m of s plus plus, like how you do in just mapping question. You will first see how many times it has occurred before, and now you will again increment its count for the future elements. Yeah, that's about it. Let's create a c is equal to 0, and I will return something like c. Hmm. It should be good, but there is one problem when you see, the difference is 0. Like when, okay, n is basically, you need to define n is equal to nums of the size. There is a problem like when you will see something like this 5, which has exactly, okay, these are basically satisfying. Some examples I've taken over here, but also you have to do if your, say, some modulus k is equal to 0 now, then you have to do something like what, I think that's enough. It will handle that case. Let's try to submit this. Yeah, you can see pretty good efficiency. That's about this problem. The basic thing, basic logic was uh this part, like when the remainder repeats itself, which means the sum between the subarray is multiple of k, and that's why you do c plus equal to m of s. Okay guys, bye.